Bismillah ar-Rahman ar-Rahim. In this session, we'll discuss wave equation. The faster the end of a rope is vibrated, the shorter the wavelength of a wave produced. That is, the higher the frequency of a wave, the smaller its wavelength. So, if we increase the frequency, its wavelength will be decreased. So, if the speed is same, so there is a useful connection between frequency, wavelength, and velocity or speed, which is true for all types of waves. Suppose the wave of a wavelength lambda is equal to 20 centimeters travels on a long rope, and 3 crust passes a certain point every second. The frequency is 3 hertz, like this. So from this point P to Q, this is one crust to one. This is one wavelength. From this crust to this crust, this is again one wavelength, two wavelength from here to here, and this is the third wavelength. So the 3 wavelengths are there, and from point P to Q, it takes 1 second. So the frequency is 3 hertz, because 3 wavelength passes through this particular time, and the wavelength is defined as 20 centimeters. So 3 waves is 3 wavelength means 60 centimeters. So 60 centimeters passes in 1 second. The frequency is 60 centimeters per second. So speed is 60 centimeters per second. So in this figure 3.14 overleaf represents this wave motion. Then if crust A is at point A, this is at point A, this point. From here, these waves travel to reach here. This point moves to this point. From this point A moves to this point after 3 seconds. At 0 second it was here, and after 1 second it was here. So this is the 3 wavelength passes in 1 second, and the wavelength of each wavelength is 20 centimeters. So 3 wavelength is 60 centimeters. So the speed of the wave is 60 centimeters per second, obtained by multiplying frequency by the wavelength. Hence the wave equation is speed of the wave is equal to frequency and wavelength. So this is 3 wavelength means the speed is 3. 5 wavelengths means 5 speed is 5 into lambda. So in 1 second. So let's solve this some of the practice questions from the book of John Duncan and Heather Kennett. And this question number 1: a wave travel at 5 centimeters per second. So this is speed, has a frequency of 50 hertz. Calculate its wavelength. So the frequency is given as 50 hertz, and the velocity or the speed is given as 5 centimeters per second. So the wavelength is this. So velocity, speed is equal to lambda into frequency. So lambda is equal to speed upon frequency. So the speed is given as 5 centimeters per second, and the frequency is 50 cycles per second, and or 50 hertz. So this second will cancel, and this is centimeters is given. 5 divided by this 50 is 0.1 centimeter. So the wavelength is 0.1 centimeters. So when this multiply with 50, then it becomes 5. When we multiply with f50 hertz, then the velocity speed will be 50 centimeters per second. So this is very easy. And question number 2: a wave has a speed of 10 meters per second, and the wavelength is 1 meter, and calculates its frequency. So it's very easy. It can be easily be understand that the frequency is 10, because when multiply with the frequency, we'll get this. So speed is 10 meters per second, wavelength is 1 meter, frequency is 10, v is equal to lambda f is equal to v upon lambda, v is 10 meters per second is given, and the wavelength is 1 meter, and we will get this 10 per second, that is 10 hertz. So this is easy. And question number 3, a wave traveling at 10 meters per second has a wavelength of 25 centimeter. So the wavelength is given, lambda is given as 25 centimeter, and the wave speed is 10 meters per second. So this is the speed of the wave, and we have to find the frequency. So v is equal to lambda f, f is equal to v upon lambda. So this is 10 meters per second, and we have to convert this 25 centimeter into meters. So it becomes 0.25 meters, and meter may be cancelled with this meter. So this is 40 hertz. So the frequency is 50 hertz. So here we have to convert. So this question 3 is more and more important. So this is the wave equations that we have learned from here. This is very important topic, and the next session we will discuss practical work.